Oh, forgot I turned my microphone on. Sorry about that cough right into the microphone there. Ha. It's probably a good thing I wasn't singing to myself when I just randomly had my microphone on, because I do that sometimes, and well, you've seen it in class. Okay. There's only 3 of us, but you know what? We're the only ones that matter right now. Oops, I'm recording. Everybody else matters too. All right, guys, we're going to talk about section 5.1. I'm going to make my screen all better for everybody. I cannot minimize, so I will get where I'm going, I promise. Actually, I don't think we're going to use WebAssign at all today. I think I'm just going to just do the notes. So let's go from here. First of all, make no doubt about it, I do miss being in the classroom. I get more work done when I'm at home, but I feel better about what my students are getting when I'm there in person, because I get that instant reaction. However, one, adding video is going to make the audio worse for you. So if you turn on your cameras, that's just stupid. I hate it when people make students do that. I mean, shoot, I'm being recorded. I got to shut up. Let's do some math, y'all. Okay. Section 5.2, the natural logarithmic function and integration. So this entire section is based off of one premise. We know that the derivative of the natural log function is 1 over x. And we know that. We got that from yesterday. So long ago, we've known it forever. But that also means, right, if the derivative is 1 over x, then the antiderivative of 1 over x must be the natural log. And that is absolutely not true. Let me fix that. Okay, you go away. You come over here. Right here. This is not true. So let me fix it. We should have an absolute value around the natural log of x. That absolute value is absolutely necessary. Totally red ink worthy. The absolute values will be the most frequently missed thing on the homework. So don't be the one that I write back with, don't forget absolute values. All right, so I mean, it's obviously hard since I can't even get it in there right. Oh, that's a little dot. Let's make that dot go away. There we go. It's not times, it's just the absolute value. Better. Okay, so we're going to use that idea. We're going to use the idea of our format as 1 over x, and we're going to do this again using mostly substitution. I could show you a bunch of examples with antiderivative of 1 over x, but it's always going to be natural log of x, so those are boring. So let's do this instead. Let's let u be x to the 9th plus 4x. Then the derivative of u is 9x to the 8th plus 4 all times dx. Look at that. 9x to the 8th plus 4 dx is taken up. So this integral becomes the integral of 1 over u du. Well, that was pretty quick and easy. We know that this is the natural log of the absolute value of u plus c. Make sure it's capital, not lowercase, because WebAssign cares way too much. And then we reverse our substitution, not in red though, red's annoying. And we'll end up with the natural log of the absolute value of x to the 9th plus 4x plus c. All right, so reverse our substitution. And that's it. that is the entire section. Everything's going to end up being in the form of a 1 over u in some way, shape, or form. We're going to do some algebra repeatedly to get these u substitutions. All right, I am going to save us some paper in case anybody is the type to print these off. Let's look at number 3. For number 3, now we're tempted, right? Let's let u be x, but then that doesn't change anything, right? Don't get in the habit of just making it the denominator. I'm not really substituting anything. I'm just replacing the variable. So what else do we have going on? Maybe we'll let u be the natural log of x. And that's going to be okay because we know that the derivative of the natural log of x is 1 over x dx. And really, what do we have here? We have the integral of the natural log of x cubed times 1 over x dx. So we have our du, we have our u to the third. This will be the integral of u to the third du, which we all know to be u to the fourth over 4 plus c, right? So our answer is not always going to be the natural log. Woo! I don't know what happened there. Our answer is not always going to be that natural log, right? Our substitution somehow involved a natural log, but our integral didn't. That's okay. We reverse our substitution. This will be the natural log of x to the 4th power all over 4 plus our constant. Reverse our substitution to go back to the original variable. All right, how are we doing? Any questions? Fantastically, I got one piece of feedback. That's all I need to move on. Yeah, how about we hit save real quick, make sure this is saving. I have it on auto save, but with the pen, it's a little weird sometimes. All right, now evaluate the definite integral. Remember, we substitute twice. Always substitute twice. In this case, when I look at what's going on with 7 versus 2x plus 1, it looks like the hardest part is in the denominator. So I'm going to let u be 2x plus 1. Then the derivative of u is 2 dx. But there's more. So this is our first substitution. Also, when x is 0, all right, let's make our second substitution. When x is 0, u equals 1, right? When x is 0, 2 times 0 is 0. 0 plus 1 is 1. When x is 4, u is, let me see, 4 times 2 is 8. 8 plus 1 is 9. Okay, we can handle that. So we make 2 substitutions so that when we rewrite this one, right, the integral from 0 to 4 of 7 times 1 over 2x plus 1 dx, right, 7 is just it didn't get taken up. So I'm going to put 7 over there. I'll probably move my 1/2 du to the other side. This will equal, right? So that 7 is just 7, that's just hanging out. Instead of x equals 0, we're going to use u equals 1. Instead of x equals 4, we'll use u equals 9. Now the 1 over 2x plus 1 just becomes a 1 over u. But we don't have this 2x. What we have is 1/2 du equals dx. So I'm going to put the 1/2 here, throw down a du. But 1/2 is just a constant. 1/2 is no big deal. It'll come out in front with that 7. And we'll have 7/2 natural log absolute value of u evaluated from 1 to 9. That's a u. It looks like an h. Let me see if I can make it better. There we go. So this is 7/2, the natural log of 9. We don't need absolute values anymore because the 9's already positive. You can keep the absolute values and that's fine. But the absolute value of 9 is always going to be 9. Subtract from that 7/2 times its natural log of absolute value of 1. But we know that the natural log of 1, I don't know why I used absolute values on 1 and not the other. I was probably thinking ahead. Natural log of 1 is equal to 0. So this is just 7/2 natural log of 9. And we could actually probably make it better than that. We could find our decimal approximation. And to do so, we'll bring up the little handy calculator here. Maybe throw it over there. 7/2 times the natural log ln of 9. Close parentheses, and I'll get 7.690. All right, let's put it down here too. 7 point. Yeah, let's mess it up down here too. There we go. 7.690. As long as you substitute twice, right? I'll come back to this. Don't worry, for those of you still writing. Here, I substituted once. And I brought it back to X, and I substituted twice. Every time we use substitution, right? We sub once. And here we sub twice. Every time we use substitution, we substitute twice. With indefinite integrals, it's in that last step that we'd make our reverse substitution and take it back to X. But if we're looking at numbers and we're looking at definite integrals, right, an actual area, we're going to do our substitution, both of them up front, so we never have to remember to go back. It's that remembering to go back that really screws up a lot of math students throughout the world. All right. As I stall a little bit, just in case people are still writing. I know you like to watch while I do it, and then you write it to catch up. So I'll stall. What was I gonna say? Oh, your video from yesterday and the video from today. I had to catch up on my email, which with advising season, it was flooded. But today I'm gonna get the captions on the video from yesterday, this video as well, and I'll get them both posted. I promise that will get done today. It's just one of those things. Sometimes I struggle at getting stuff done. Okay, we've all been there, right? Okay, here we go. Evaluate the definite integral. So again, and now I'm looking at this and I'm thinking, well, I can't really do this either way. So what do I do? Because of the section that we're in, let's let u be that denominator, because we can never manufacture a denominator. Then du is 1 dx, right? 1 is the derivative of u, and so dx. So I'm thinking, what am I thinking? When x equals 0, u equals 1. When x equals 1, u equals 2. So I got my two substitutions. But how is this really going to work? We also know that x is equal to u minus 1, right? If I subtract 1 from both sides. So let's play around with it a little bit. The integral from 0 to 1 of x minus 1 over x plus 1 dx. Let's substitute what we can. Instead of from 0 to 1, we know that u goes from 1 to 2. I know I have a u in the denominator. What's going on with this numerator? Well, we need to replace this x, and that's why I solve for it down here. All right. So I get u minus 1, which is the integral of from 1 to 2 of u minus 2 over u du. Now, at first, it doesn't seem like it's very helpful at all, but it is actually going to be extremely helpful. Notice that, and these are U's, not N's, this lazy N's or H's. Notice that we could actually divide this up now, separate it. I'm not going to say divide it. We don't have a quotient rule, but we have U over U du minus the integral of 2 over U du, right? If we have two things that we're subtracting over a common denominator, well, it's a common denominator. So U minus 2 over U, think about going backwards. We're all cool with adding U over U, or subtracting U over U minus 2 over U. We're just undoing the common denominator thing. This becomes the integral from 1 to 2 of 1 du minus 2, the integral from 1 to 2 of 1 over U du. Now, how would you think to do this? You would show up for class and I show you. That's how we all learn. That's why you're here. All right. So now we're looking at two antiderivatives. And I'm going to bring it over here. We're going to take this to this side. So I'm not just using half of our page. The integral of 1. What has antiderivative 1? U has antiderivative 1 in our du world. So we're going to evaluate that from 1 to 2. And then we're going to subtract 2 times the natural log of u, absolute value of u, also evaluated from 1 to 2. So we have 2 minus 1. All right, I'm going to put a little star of a different color, slightly different color. And we have minus 2 times the natural log of 2 minus the natural log of 1. And we all, of course, remember that the natural log of 1 is 0. So we will have 1 minus 2 natural log of 2. And when we get to this point, and I've used the whole screen and I can't see the problem, I go back and I ask, oh yeah, 3 decimal places. All right. And so I'll use the calculator and I'll find 3 decimal places. And we get 38629. So our answer will be a negative 0.386. But I don't want you to forget, right? I'll let you see the screen again. Absolutely. Let's see what I have going on this screen. I'm glad it wasn't something that was going to expose my inner whatever. I have to cancel a orthodontist visit, but other than that, nothing good going on. All right, so we have x minus 1 divided by x plus 1. Why would I do it here? I don't know how to integrate here, so that was a bad idea. Sorry. What we actually want to do is bring up this calculator, and we're going to put in x minus 1 divided by x plus 1. We're going to graph that. And then we're going to find the value of this integral. We're going to go to calculate. It's in blue, so I'll use the second function trace. Option number 7 is the integral. Our lower limit, because I'm using x here. I'm not using the u. I'm using the original. Lower limit, x is 0. Upper limit, x is 1. Negative 0.3862944. All right, so you can always check these answers. All right, anytime it's a definite integral and you're getting a number out of it, number 6, number 7, you could do those completely on the TI. An indefinite integral, you cannot do on this calculator, but you could do it on a TI 89. And that's why we don't allow graphing calculators in this course, is because they can just complete, or yeah, I'm not using this calculator over here. You can't see that. That's why we want to make sure you understand the work and not just technology. All right. I've been rambling a minute. How we doing? We good to move on? All right.
All good.
Fantastic. Appreciate the feedback. All right. Now, this question, or one very much like it, will be on a quiz for this section, must be quiz 11. And it will also be on the exam. I guarantee it. This is the second fundamental theorem of calculus. And I can tell you, here's what I'm going to do. I'm going to tell you exactly what this answer is. It's 9 over x squared plus 6 times 2x. So in this case, mine will be 18x over x squared plus 6. And all I did, I'm not going to tell you all I did. I'm going to show you how I got that. Now, this is using the second fundamental theorem. But let me show you why that's true. All right, we want to find the derivative. So first we find f of x. And to find f of x, no big deal. All right, we can do that. Because we'll let u be t plus 6. And then du is 1 dt. And so this becomes, oh, let me see. When t equals 0, u equals 6. When t equals x squared, u equals x squared plus 6. Okay. Right? T is 0, 6. When t is x squared, yep, okay. So we now have from 6 to x squared plus 6, 9 out in front. Let me fix that equal sign. That 9 I pulled out in front will have 1 over u du, which is 9 natural log absolute value of u evaluated from 6 to x squared plus 6, which is 9 natural log absolute value of x squared plus 6 minus 9 natural log absolute value of 6. Okay, this was from today. All right, this bottom line here, that's what we've talked about today. We've only just now been able to evaluate this antiderivative. But remember, this is now like f of u, because we did a little switchy of variables here. When we take the derivative and we put it back, all right, so first I'm going to do f prime of u, and wherever I have a u, I'm going to put it back in terms of x's. All right, we'll reverse that substitution. Hopefully this works out for me, because I got to tell you, I've never done it like this before. And I kind of like to live on the edge of life and just do random calculus while people are watching, to see if I still can. Not true. This derivative, what is this derivative? This derivative is, leave the 9 alone. The derivative of the natural log is derivative of the inside divided by the inside. And the derivative of, oh, that's just a number. And now that I think about it, now that as I'm looking at this, this is f prime of x because everything here is in terms of x. Well, the derivative of a number, a constant, is just 0. What did I get? I got 18x over x squared plus 6. I got exactly what I told you we were going to get. Now I know that's not super impressive to you guys because, like 80% accuracy for me in this class, it seems. Maybe a little better, but how was I able to do it without doing this? Check it out. Our original, I'm going to change colors in this so we can talk about it. This original, and I'm going to rewrite it down here so I can break it apart for you. F of x is from 0 to x squared, 9 over t plus 6 dt. So to find f prime of x, step 1, replace t with the variable limit. All right, 0 is not a variable, x squared is a variable. So I'll have 9 over x squared plus 6. Step 2, find the derivative of the variable limit and multiply. All right, so I don't know why I took those values with me. There we go. Multiply. So what's the derivative of the variable limit? 2x has derivative, x squared has derivative 2x. Now we put them together. And we'll have 9 over x squared plus 6 times 2x equals 18x over x squared plus 6. So your choice now becomes, do you want to do all the work of the calculus and the step-by-step and the details of it in blue, right, which you're totally capable of doing? Or do you want to be able to look at it and say, hey, I know what this is going to be because I know that the derivative of an antiderivative is the original function, but it's the original function with a little adjustment. All right, so watch for that. It's pretty interesting, and I'm going to throw out another example of this actually instead of moving on to our next concept, our next problem. Come on. So if we have, for example, hint, hint, might be on a quiz or something. We might have f of x is the integral from 0 to sine of x of 3 square root of t dt. We know automatically that f prime of x will be 3 square root of sine x times, and what's the derivative of sine? Cosine. That's it. All right. Replace t with variable limit and multiply by the derivative of the variable limit. That's it. All right. And I think something very similar to this was on previous homework. And that's why I wanted to show it to you, because it could end up being on your hint, hint. quiz and or exam. Are there any questions on this second fundamental theorem or the actual example from the homework that I did?
No questions.
Yeah. Oh, no questions. Okay.
No, yeah, no questions. My bad.
No, that's all right. I thought I heard quick question, but I don't listen any better at home than I do at work. All right. Fantastic. Don't let me scroll too fast. Even though it's recorded, even though I'm posting this, if you want to write it down, if you have questions, make sure you let me know. Look at us just cruising right through. I'm going to bring this up a little bit just so we have more room. Find the average value of the function over the given interval. By the way, I think I answered WebAssign somebody wrong this morning. I haven't figured out who that was yet because I haven't gone back in. So for those of you that asked questions on WebAssign last night, after class, I'm going to go back in and check the answer I gave you on the average force. I think there was an issue with that. I'm not entirely sure. I have to go back and look at it. That applies to one person, and I honestly don't even remember if they're here today. So the average value of the function. Remember, this came from the mean value theorem for integrals. Mean value theorem for integrals. It was right in that section. And the average value for a function, I typed the formula here for us, just as a reminder. In order to find this, right, we find the total area and we divide it by the height. That's all it is. It's total area. And it, like, seriously just occurred to me. All right, total area divided by the width of the interval. And that's going to give us our average height. So in this case, the integral from 1 to e of 1 over e minus 1, I forgot that part. 18 natural log of x all over x dx. All right, let's pick a new color. Let's go with purple. So I have a couple of choices here. Let u equal x, but we can't create that natural log of x and is just change of variables. But not helpful. All right, let u equals x. We can't create the natural log of x, so that's probably not going to work. So maybe we'll let u be this natural log. When that happens, keep in mind that du, oh, that's right. The derivative of the natural log is 1 over x. I can manufacture a denominator now. And I mentioned when we first did substitution, I think that's when we were in class last week, it's really hard to manufacture denominators until we start dealing with natural logs. Then we're all good. All right, we can handle this. That's cool. Let me see if I can rewrite this a little bit. 1 over e minus 1. The integral from 1 to e. Heck, let's throw that 18 out in front too, right? 1 times 18. I'm going to call this natural log of x. And then instead of dividing by x, I'm going to multiply by 1 over x dx. And now it's a lot easier for us to see du, u. And now I just have to change my these are called limits of integration. Woo, limits of integration. So when x equals 1, u equals the natural log of 1, which is 0. And when x equals e, u equals the natural log of e. What power do I put on e to get e? That's a 1. If you need to, right? If those logarithmic powers are kind of messing with you, we can always remind ourselves, even on graphing calculator if we happen to. This is just e to the first. That's just e. It's just 1. And don't make it harder than it needs to be. If it hurts your head to look at that at this time of the semester and this time of your life, because life kind of sucks right now. My wife's not coming home today. Man, be good to yourselves. Life sucks. Anyway, the natural log of, but it's still worth living. Every single moment. I wouldn't change it for not being here. If you need help, reach out to someone you know, and I'm always here for you guys. Seriously. 0 to 1, we'll have, sorry, I get off on tangents because it's hard to keep your thoughts straight some days. 18 over e minus 1 times, all right, the antiderivative of u is u squared over 2. I'm going to evaluate that from 0 to 1. And when I have this weird coefficient, right, this 18 over e minus 1, I don't know why I wrote u squared over u instead of u squared over 2, perhaps because they're rhyming. I'm going to leave that whole thing out in front, and I'm going to do 1 squared over 2 minus 0 squared over 2 in parentheses. Instead of putting this 18 over e minus 1 times each of them, it's frustrating. So I just leave this coefficient out front and only have to deal with it once instead of twice. This is 18 over e minus 1 times 1/2, which is 9 over e minus 1. I am absolutely sure that they want us to round somehow. So I'm going to do 9 divided by e. It's the inverse of the natural log function. So it's here in blue, second function, natural log. E to the first power, if there's no power written, it's automatically the first power. Mathematicians are lazy, calculators aren't. 5.23. I don't remember if it's 7.7 or 7.9. 7.79. Let's see, 3 decimal places, 5.238. The average value. So you can find the antiderivative, right? You can find this integral, this definite integral on your calculator, right? You can find that this area is 9, but in order to find the average value, you still have to divide that. So be careful if you start to choose to do these on the calculator. Make sure you know what part you're doing there on the calculator and what part you cannot. Seems like every day we only have a 50-minute class and I only take up 40 of those minutes. The other 10 minutes are usually banter in the classroom back and forth. Stalling for a moment while people write down what they need. Are there any questions on this example? Or questions on anything from a previous section or even a different problem from this section if you've already started it? Let's throw those in the chat in case there are multiple ones instead of just telling me, because we've already established I cannot listen.
There's a question on 4.5, I believe. I'm at the gym, if I'm being 100% honest, so I have no idea which question it is. But I can't get it. I don't know if you can see my attempts.
I can, but I don't want to bring
assignment.
I don't want to bring it up because everybody could see your grades and I'm recording and then I'd have to edit and I suck at editing. So let's look at 4.5 and you tell me when to stop.
Okay, let's see. I think it's like towards the end, if I'm not mistaken.
Yeah, let's start at the end and go back.
Yeah, it's 14. Yeah, it's 14.
Yeah, of course it's 14.
Sorry.
No, that's the one problem I don't want to do. Ha! I'm gonna do it though, don't worry. All right. I'm going to put these side by side for this. So let's make sure. Yep, I got extra pages here in case we need them. So look at 4.5 number 14. And let's be smart about this. I'm just going to clip it, post it in here so that we all have this version written down. All right. And then we don't need the other page. The oscillating current in an electrical circuit is as follows, where I is measured in amperes and T is measured in seconds. Find the average current for each time interval. That's the exact thing that we just talked about. The average current, since this is the current, we're going to be looking for 1 over b minus a, the integral from a to b of I dt. All right, always this I. And it depends on our interval, right? Our interval is always 0, 2. And that's cool. We can make this happen. So I'm going to do one of these. I'm going to do B. A and C are exactly like this. We do the process 3 times. So B. So I want to find 1 over 240 minus 0, the antiderivative from 0 to 1 over 240. You can see why I wasn't interested in doing this problem, of 7 sine of 60 pi t plus cosine of 120 pi t dt. A couple of notes. First of all, I almost never do the last problem on an assignment because I always want you guys to try it first, but I always expect that I'll get to it in another class period. So yeah, there's probably a physics one we're going to do tomorrow, the average force, when everybody catches up to that one. But we'll see. So I totally expected this to be a question eventually. Second point I want to make is, although this antiderivative and the dt are kind of like bookends, we have to remember to put this all in a parentheses because we have to make sure that dt is distributing to everything and this integral is distributing to everything. And this is just a notation thing. It's a notation thing that honestly makes absolutely no difference in the world. Like, seriously, come on. It's like putting the I in the numerator instead of next to a number. It's convention, it's notation, it's not changing the point of it. However, some of my colleagues in future calculus courses will take off points if you are not appropriately parenthesed. So make sure you get that in there. Okay, fortunately, this does not have much substitution. I mean, it does kind of. We'll make a substitution in order to deal with these. U equals 60 pi t. So du is 60 pi dt. Over here, I'm going to use a w equals 120 pi t. And then dw is 120 pi dt. All right, so it's kind of a double substitution. But kind of not. Here's how I'm going to do it. This is 240. All right, 1 over whatever. 1 over 240 minus 0 is 1 over 240. The reciprocal of the reciprocal of 240 is 240. I'm going to leave this. Oh. How am I going to do this? I'm going to do this like I would actually do it. 240 out in front. I'm going to multiply it by some stuff. Now, that 7 is going to stay there. The antiderivative of sine is negative cosine. When we leave the inside, like, right, if this were a u, it'd be negative cosine of u. But remember, we have to adjust because we don't have this 60 pi dt. So this will be 1 over 60 pi. How do I want to say this? Yeah, that's kind of how I want to say it. That's it. That's end of story. I have to adjust for this, right? So the du would have been 1 over 60 pi du equals dt. So that 1 over 60 pi is kind of going to be coming out front, but we have 2 of these. So I'm just going to leave it sitting for now. I'm going to change colors just in case we need to ask about these 2 different things. I'm going to make them blue and orange. Come on, let's go dark green. All right. The antiderivative of cosine is positive sine of W. But we didn't have that 120 pi to hang out with our dt. So we have to make sure that we offset by that as well. All right, so I'm going to do one as an example, the integral of cosine of W times 1 over 120 pi dW equals sine of W over 120 pi, which is sine of 120 pi t over 120 pi. So in this way, I don't actually ever use W. And since it's a definite integral, you know how we usually switch variables first? I didn't switch variables on this one because I knew I was going to have to do a little work on each one. And so I wanted to do the work with bringing it back to t. That way I could leave these the exact same. This problem sucks. I'm so almost sorry that it's assigned. Almost, because I like calculus. Okay, so 240 times minus 7 over 60 pi cosine of 60 pi t. Oh my goodness, this sucks. I want to evaluate that at 120. Oh my goodness. Leslie, you're killing me. I'm good. I'm good. I'm not making you feel bad.
I'm right there with you.
All right. Is everything rolling smooth so far?
Yeah, it makes sense.
It makes sense.
I kept getting stuck right there because I kept trying to change like the values of which you're going based off of the 0 and the 240. And I think I just really confused the crap out of myself.
Yeah. Yeah, I'm about to do the same. So I'm going to try to write it small up here. Cosine of 60 pi 1 over 240. That looks like GOT. I swear we're not back to Game of Thrones here. 1 over 240 times 1 over 60 pi minus, oh, geez, I don't even like that. 240. Massive, massive blocks. All right. So this minus 7 in the 60 pi. And then I'm going to evaluate the cosine of 60 pi over 240 minus cosine of 6 pi times 0. To that, I'm going to add 1 over 120 pi times the sine of 120 pi over 240 minus the sine of 120 pi times 0. Exhausting. All right. 0 times whatever, that's 0. Sine of 0, that's 0. Fantastic. 120 pi over 240, this is pi over 2. Sine of pi over 2, okay. 0 times 6 pi is 0. Cosine of 0 is 1. 60 over 240, this is going to be pi over 4. So then I am going to type into my calculator with as many parentheses as I can muster. -7 over 60 pi, probably throw some parentheses down here, times multiplied by the cosine of pi over 4 minus 1, don't close that parenthesis, minus 1 plus 1 over 120 pi times the sine of pi over 2. Boom, done. Done. Just big honking. And then that equals some decimal. And that is 1/3 of that problem. I would like to point out this is 1 point. 1 point is all that is. You get to decide how much effort you want to put into that 1 point. I'd put effort in because you're good students, but okay, now I have to remember, how do I bring back my share menu? I know it's here somewhere. Let's go with Control S for show. I don't know. No, undo. I don't know what I just did. No, don't save. Not sorry. Anyway, that's done. Coming back here. How can I stop sharing? Does anybody remember the menu commands? Son of a biscuit hatcher.
No, I have no idea what the commands are,
Yeah.
but thank you.
I know. Let me see. I know this. Oh. No, not Control H. Ooh, what was that? Control F. Not very useful. That's it, I guess. I'm gonna figure out how to get off of here, and in the recording, I'm going to trim it. I should have reminded myself where those buttons are before I hit the menu. I swear it's Control H. Unhide. Shoot, I don't know. Have a great day, y'all. Stick around if you have questions, and I'll make this happen somehow. Back here tomorrow, maybe my wife gets out. Tomorrow, if I don't show up in time for class, that's where I am. It seems as though they release people right around 10 or 11. And I hate to put you on a string like that, but we'll make stuff happen however we need to make sure that you guys are ready to go. Thanks for your time. Here I go, trying to figure stuff out.
Thank you. Will these videos be on YouTube or on Blackboard?
I'm gonna upload them to YouTube, but I'm also gonna post on Blackboard.
Okay, thank you so much. Have a good day.
All right, you're welcome. Control Alt Shift. Nope. Nope.